Welcome back to my YouTube channel. Today we'll be dealing with mathematics N6. This is the introduction to partial differentiation, right? Differential. If you have not subscribed to my YouTube channel, may you kindly subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post a new video. And then if it's your first time watching my video, you may also kindly subscribe as we indulge together in this video. All right. You have given unit 1.2, which is the partial differentiation. So as you know that in the previous N4 and N5, we've learned about uh, to differentiate, right? But they were dealing with function of one variable, right? What I'm trying to say, we differentiated if we have function of one variable. Like here we see it's x, right? So or here we have x, one variable x, we have x that is consists of what, of one variable. Now in N6 level will be introduced to two, even three variables, depends, even three, sometimes maybe four, but often it's two up to three, right? All right, will be introduced to such variables. All right, so um okay, if we look this, let's check here. It says here in the practical situation, we come across the numerous example of function of two or more variables. For example, here we've given Z, the total population of what, of a country, X, the number of male, Y, the number of females. As you can check here, we have consist of how much? One, two. We have how many? Two variables, right? So this can be written, you see, or this can be written in this form. Uh, X and Y represent that we have what, indicate that we have two variables. They can be written in that format, any format that you are comfortable with. You can write any format that you're comfortable with. It's up to you, by the way. All right, so that is what we have there. So for example, let us look at another example. If you have a volume, uh, the volume has a radius and a height, for example here. So here we consist of how much of, here's a radius, it has the radius and also has a what, a height, which is have two variables. We can write this in this format. We are focusing on the variable. We have what, r and h. So we have two variable in this format. We have two variables, right? All right, so this is what we now what we call. So since you have seen you have two variables, now is the moment. Now what differential will come. What is important about the partial differentiation. Partial differentiation will differentiate in respect to a certain variable. Will take a differential to the certain single variable, right? For example, here as it says, is written as follows. You have here, for the differentiation of function of more than one variable, we differentiate with respect to one variable, right? While taking the other variables or variables to be constant. The other way, taking them to be what, to be constant. This is strictly called partial differential. We call that partial differential. For an example, we will see here. Here is the symbol that we use for this symbol, like that, represent partial. Is for partial differentiation, right? So okay, for today we'll be dealing with first order. We'll look at first order. We'll look at what we call first order. Here we'll look at first order partial derivatives. Let's say we have, let's say if they say if z is a function of two variables x and y, then the partial derivative that you will take, what they are trying to say, they're trying to say, for an example, of two variables, let's say we have z, it's equals to let's say it's equals to what, to x plus y, like that. All right, so as you can see, if we differentiate, partial derivative with respect to x will be represented like that. You see here we'll have that in respective to what, to x. That means we'll differentiate only this part that has x. This one will take it as a constant. We'll take it as a constant. We'll consider it as a constant. So partial derivative of z with respective to y, as you can see here, with respective to y, we have dz over dy. That means here, now we'll differentiate y, then this will take it will be what, a constant. That is what they're trying to say. We'll take that as a constant. All right, we'll take that as a constant. Actually, you'll see when we are dealing with some example there. You will see when we are dealing with some example there. All right, so again, it can be represented. We can use this notation. If the f of x, we can use like that. We can use this format. You see, let's say we have y is equal to x plus y. We can use this format here. If we differentiate, we can use this format. We can say all right, we can say f of x. Here I write a little f of x, there I write a little x like this, x into what, y. Then that means here I consider what, x. I will differentiate x. This means in respective to what, to x. This will be considered as a constant. This will be considered as a variable. Is the one that will differentiate there. It's a one and the same thing. We can either use the format above, or use this format. The partial derivative with respect to x will be f of x. Here you see there's a little x there. You see that x, well, you can use this format. When in respective to y, you do that. So hopefully you understood this, guys. Okay, you'll see when we are dealing with some example. All right, you will see when you are dealing with some example, right? So again, we can be given, sorry about that alarm noise. Again, we can be given three variables. As you can see, guys, we can be given three variables. As you can see them, sometimes you can be given three variables. They were given the function of x. If we have given x, y, z, let's say your w can be represented using that manner, or you can use the partial derivative. That means here we have partial derivative of w respective to x. That means we'll only differentiate what, x there. The remaining variables will become constants. Become constants. So okay, nevertheless, let us try and if you can put this into practical. This is let us find the first order derivative. We'll see how to deal with the first order derivatives, right? For an example, This is in first order. For an example, we've given example 1.4 says find they've kindly asked us to find the derivative of to find the partial derivative of z of z in respective to what, to x, and then of z in respective to what, to y in the following cases. All right, we've given number one there. Number one here, we've given z is equals to x cubed plus y cubed, right? So we should find the partial derivative of z in respective to x like this. All right, this will be equals to what? Remember, in respective to what? To x, guys. In respective to x will be a variable. Y will take the y. We'll take y as a constant. We'll take y. We'll consider y as a constant. X will be a variable, right? We'll take x to become. We'll consider it as a variable, right? All right. So this will simply equals to what? You differentiate, you drop the exponents, will be what? 3x, you minus 1, use the power rule there, you'll be 3x. This one, remember, this will take it as a constant because what differentiate to respective to what? To x. That one will simply equals to what, guys? Simply 0, isn't it? Because it's just a variable. Then these guys will simply equals to 3x squared. All right. Hopefully you see this. So again, we have given the number 2. The number 2 we've given z. Number 2 we are given number 2 there. Z is equals to 4x raised to the power of 3 plus 3x squared y plus 2xy squared plus y cubed. All right, this is what we have right now. Okay, guys, so we should differentiate. Okay, we'll come to this path here. We'll differentiate. We'll come there. I want us to deal with this part first. Okay, we're supposed to find this and that. In this case is okay, we'll come again and find this one using that rule. So I want us to understand through this one. Here we'll take partial derivative of z in respective to x like this. Anything that remember, anything that does not consist of x will be a variable. This is a variable. This is a variable. Oh, sorry, that is a constant. Sorry, okay, sorry guys, anything that not consist of x will be a constant. That is a constant. It's a constant. So do not use a product rule here, guys. Do not use a product rule. All right, so this will simply cost what? You drop the exponents. 4 multiplied by what? By 3x minus 1. There on the exponents will have 2, right? Plus you drop the exponents, will be 3 multiplied by what? By 2x when you minus 1. Y is simply just a constant. You write it as it is. It's simply just a constant, guys. So plus do not multiply by these 2. It's simply just a constant. So we focus on x raised to the power of 1. You will multiply this, you drop multiply by 1, you minus 1 will be simply equals to what? 1. This will be 2. Remember, x will simply equals to 1. We have there y squared. Then here, this is simply just a constant, guys. That is simply just a constant. So that will be plus 0. All right, hopefully you understood this. This will simply just 0. This is simply, here we'll have 4 multiplied by that, which is 12. We'll have 12 here, 12x squared, all right, plus 6, 3 multiplied by 2 is 6, x, right, y, plus, this is 2 multiplied by 1, this is 1, this will simply equals to 2y squared. So this is what we have so far, guys. All right, you see, with this respective to what, to x, we differentiate in respective to what, 2x. That is what we did there, guys. So now we can differentiate this in respective to what, to t. Let us do this one again. Now we'll use this in, will be in respective to what, partial respective to y. So we'll use we'll try and, now let's come to this number 1. Now we did this. Now I want us to remember our equation. We still have this equation, guys, that says is still x cubed plus y cubed, right? So now let's take partial derivative with respective to what, to y. Right here we have y now. This will be equals to what? Remember, this now will become irrespective to what, to y, guys. This will be simply what now, it will become the constant. It's the same as a constant. This will simply equals to 0. You drop the exponents, there will be 3. This will be 3. Y minus 1 will be 2. We know what you're supposed to do. This simply equals to 3y squared. You understand? So you see there. So you come, we come again to this part. Number 2, we still have what we have. We still have the same equation there. Z is equals to 4x raised to the power of 3 plus 3x squared y plus 2x, all right, plus 2xy, there we have squared, right, plus y raised to the power of 3. So this is what we have so far, guys. So now we take a derivative of z, partial derivative of z with respective to what, to y now. So x will be what, a variable. If this is just a variable, if this is a variable, remember this is like a constant. So guys, this is like a constant, will be simply equals to nice 0 there. We'll have our nice 0 plus, here check, we have y. This will be like a constant. Remember, this is like a constant, guys, that we have y. We have a power there, which is 1. You multiply the constant by 1. X raised to the power of 2 multiplied by 1 will simply equals to this minus 1 there on the y will be what, to left it will be y raised to the power of 0. Will simply, this will be equals to 1 plus, this is simply just a constant, you multiply by 2, the constant will be 2 multiplied by 2, they will have 4x like this. You have dropped the exponents, you'll have y minus 1 there. You drop the exponents, will be 3y, subtract the exponents will be 2. So this will simply equals to 3x squared, right, plus 4x y plus 3y squared. So this is what we have so far, guys. So what we did here, we call this now, this is our, that is what we call partial derivative, right? This is a first order. All right, guys, hopefully you understood that. That is simply just a first order. All right, now we have this example, guys. Again, number one there. Number one, you've given the y over z there. So we have this again there. Supposed to find the that in respective to what we have there. All right. Just know I'm trying to, let me write it on the space, guys. Here you can see this there. Let me write it there. Number one there. That is what we have there. Let me paste what we had. This is what we had there. All right, suppose now here this is z. Oh, sorry, then this is like we have z. This is the same as, guys, if you can check, this is the same as 1 over this is x. Sorry, guys, this is supposed to become x like this. All right, this is same as y, 1 over x multiplied by y. You know the maths, right? So let's take the partial derivative in respect of what? To x. All right, in respect to x, remember this will be what? A constant. Y will simply equals to constant, right? So this simply just equals to constant, and we're multiplying right here. So this will rewrite this 1 over 2 is the same as before. Coming here, let me just first rewrite this before we go there. Before we take that, I can rewrite this whole thing to become 2x raised to the power of minus 1 multiplied by y like this. All right, then I can take now our partial derivative in respective to what? To x. Then this, you drop the exponents, you know, minus 1 x, you minus 1, there will be minus 2 multiplied by this one. Remember, this is the same as a constant. They are supposed to do nothing there. Then this will be equal this will be equal you can rewrite this again. Remember, this is the same as, you can rewrite that this will be same as minus 1 over x raised to the power of 2. If you write it to the positive exponents, if you make this to become a positive exponent, multiplied by what? By y. This will simply equals to minus y over x raised to the power of 2. So this is what we have there. All right, but now let us check if we differentiate that z, we still have these guys there. Now multiplied by y. Let us now take this partial derivative of z in respective to what? To y now. All right, in respective to y. Here, remember, we have 1, guys, here. So you multiply there. Remember, this is simply just a constant. It's the same as 2y like this. This is simply just a constant. All of it is simply just a constant. So you multiply by 1. This will simply minus 1 like that. This will fade away. With minus 1 will have y 0. This simply equals to what? To 1. So it's like that. This will be 1 over x. So that is what we'll have so far. All right, that is our number 1. Hopefully you have seen, you understand these, guys. That is how it goes about. So here we have number 2. All right, here we have given this there, which is you've given z equals to sine 2x plus 3y multiplied by cos 3x plus 2y, like this. All right, so we now supposed to take the partial derivative of x and y. Let me copy this and write it here on our let us write it this on our free space here on our free space here on the bottom. All right, that is number 2. That is our number 2 here. All right, let me paste that. This is what we have. This is what we have. Sorry about this. This is becomes delete all of that. By the way, let me say here we have number 2. All right, this is what we have there. So supposed to take partial derivative of z in respective to what, to x. You can start by this. All right, now how things, okay, the derivative of sine is what is cos, positive cos, not a negative one. Here we'll simply have our cos, right, 2x plus 3y. Then you apply the chain rule, you come to the side, this will multiply this by what, by 2. This is simply what, remember y, we take it as a constant in respective to x. This will become a constant, it's the same as a constant. We'll multiply this by simply what, 2. Then that one is simply just what will be 0. So there's no need about that. Okay, I can do like this. All right, multiply okay, let us apply the product rule. Why? Is because the both these two things, they have consist of x, also it consists of x. So okay, so let us apply the product rule. Let us try and apply the product rule here. For recap, product rule, remember the product rule. For recap, if you have will simply equals to f of prime x, right, multiplied by g plus f of prime multiplied by g of prime, right? So this is our product rule. I can say I can make this this one, guys, can make this one will be x, this one will be f, this one will be just be g. So using applying, now we are following up the product rule, right? So let us apply the product rule. Partial derivative of z in respective to x, this will be equal to what? Differentiate this will be cos because 2x plus 3y multiplied by what, the product, using a product rule. Remember chain rule, come to the inside, This is the same, will be 0. That one same is constant. Multiply this by 2. All right, multiplied by what? By 2. All right, we come to G. Here it's our G. Its cos will be negative. Will be negative sign. We know will be negative sign. Then this obvious will be equals to 0. This one. Then we'll multiply by what? By 3 using the chain. Okay, this will be negative sign. 3x plus 2y multiply by what? By 3. All right, this is what we have so far. Right, we are done with that part. Now plus, now we have that plus. We have plus the original one. Oh, sorry guys, we differ. Okay, this is supposed to be the original. I'm just looking at this part. I don't know why. I feel like I'm tired today. Seems like I'm tired, but nevertheless, let me just take this part. By the way, no problem. Let me take this part. We are supposed to become that side here. Okay, nevertheless, let me just delete these guys. Let me not waste time. This simply just we'll write this as it is. G of x will be multiplied this by cos 3x plus 2y, right? Isn't it? We're following that. Then plus f of prime as it is sine 2x plus y plus 3y. All right, now we'll take what? The derivative of the last one of the cos. All right, then that will be equals to what? We'll multiply this, or multiply, we'll write here. I will write here in the bottom is continuing here. Multiply, this will be negative sine what? 3x plus y. Applying chain rule, multiply by what? By 3. All right, this is what we have, guys. There, this is what we have now. This is what we have. So this will be equals to, this is what we have. This will be equals to here, this is multiplied by that 2. I can write these 2 here. This will be cos 2x plus 3y. The original one, simply just multiply them. Be multiplied by cos 3x plus 2y. This will be plus. We have this. We'll have there. We'll have sine 2x plus 3y, isn't it? So multiply that. You can write this will be obvious here, multiplied by 3 minus 3 sine of 3x, or let me just write it here for the sake of space. Let me reduce. All right, so we'll have, by the way, multiply by we have multiply by negative 3 sine 3x plus y, like that. All right, this is what we have so far. If you may check these guys here, what we've noticed, these things are the same. They will have 2, right? That will be cos. Remember this here. Yeah, let's check. Okay, it's not the same. The angles are not the same. All right, there's nothing we're supposed to do here. The angles are not the same, so we'll have simply have this cos 2x plus 3y multiplied by cos 3x plus 2y. All right, this will be negative. This negative will affect this positive because it's multiplication. We have minus. All right, sine 2x plus 3y multiplied by sine 3x plus y. Okay. This is what we have so far. All right, this is what we have. Then this is what we have, but this you can this is a compound angle, as you can see this, right? You can reduce this, you can use a compound angle, or you can leave it here. By the way, we just have to differentiate. You don't need to go further, we are just differentiating. You can leave it here or you can go further. That is a compound angle, as you can see. So by the way, you have differentiated that. What is important for you is to differentiate. All right, so number 3 we have that. Number 3 we have z is equals to xy, like that. All right, so if we differentiate this and take partial derivative of z in respective to x, y, it's simply just a variable, guys. Y is simply just a variable. Apply the power rule. It's like we have two, simply like you have x raised to the power of 3. You drop the exponents, minus 1. So this is y will be a variable there. So these guys will be, you drop the variable exponent, which is y, will have x. You subtract what? Minus 1. So this is what you have so far there. All right, so yeah, that is what you're supposed to have in respective. Remember, you take x as a in differentiate in respect to x, in respective to x, so that one will be simply just equals to a variable. So likewise, if we have that again, x, y, now we have to take partial derivative in respective to y. Okay, x becomes a constant. Okay, this we take this now as a, this will become a variable, the y, as you can see. Then this is an exponential, right? Remember, when you are using exponential, or this will, you'll write this as it is. We'll have that this is an, you drop, Remember, it is supposed to take to differentiate y, but will become 1. So if you multiply by 1, there's nothing will change. You'll have x raised to the power of what? Of y. We're supposed to multiply by the derivative, but derivative of y is 1. Multiply this by, remember, ln. Then the base, we take the base, which is x. Base what? Ln x, like this. So this is supposed to have there. That is what we're supposed to have. All right. That is what we are supposed to have there. So number 4 here, we have all nicely this. We have our z is equals to sine the inverse